Hello and good afternoon, everyone. Today, I am going to solve for the derivative of each of the following functions that were given during our final examinations. And to start with, we are given with the first function, which is f of x equals y times the square root of x plus 1 equals 4. So this type of differentiation is an implicit differentiation in which y is mixed with x and y is not yet isolated, and therefore we are going to differentiate both sides with respect to x. So the reason why we equate it to 0 on this process, it's because the derivative of 4, which is constant, again will always be 0. And from the left side, which is y times the square root of x plus 1, we obtain y prime times the square root of x plus 1 plus y times the quantity of 1 all over 2 times square root of x plus 1. So why have we obtained this function? This function is obtained, or differentiation is obtained through the formula used from the product rule, which is udv plus vdu or vdu plus udv. So our y there, that would be our u, and the square root of x plus 1, that would be our v. So applying the formula for the product rule for differentiation, it gives us y prime times the square root of x plus 1 plus y times the quantity of 1 all over 2 times the square root of x plus 1. And yes, that would be equal to 0. So the next process of this one would be, we are going to isolate the y prime along with the square root of x plus 1. And then we are going to transpose this second term on the right side. That is why we have obtained a negative answer. So that would be negative y times the quantity of 1 all over 2 times the square root of x plus 1. And then in order for us to obtain or to totally isolate the y prime, as for our answer, all we just need to do is to divide y times the quantity of 1 all over 2 times square root of x plus 1 by the square root of x plus 1. So by dividing this, we have obtained negative y all over 2 times the square root of x plus 1. So moving on to our number 2, we are given the function f of x equals 5x squared all over x plus 47. So this function can be differentiated through the formula of using the quotient rule, which is v du minus udv all over v squared. So 5x squared would be our u, and then x plus 47 would be our v. So that is why we have x plus 47 squared. And x plus 47 times 10x, since x 47 would be our v, and then 10x would be the derivative of the u. And then minus 5x squared, which is our u, and then the derivative of our v, which is 1. So by applying operations, by multiplying 10x times x plus 47 minus 5x squared, we have obtained 5x squared plus 470x, and then we are just going to copy the denominator, which is x plus 47 squared, or we can simply simplify this one or getting the factor from the numerator, which is the factor of 5x squared plus 470x is 5x, so therefore we have isolated 5x, and then we obtain the quantity, which is x plus 94, and then all over x plus 47 squared. So that would be our answer for number 2. By the way, if you are confused with the formula here, this is actually v v du minus u dv all over x plus 47 squared. That is why we obtain this process. Moving on to number 3. We are given the function f of x equals 2xy minus y squared equals 1. So this is the same from the first one. So we are going to differentiate both sides. So that is why we have equate the function to 0 because the derivative of a constant will always be 0. And then the derivative of 2xy would be 2 times the quantity of xy prime plus y minus 2y prime, which is the derivative of negative y squared. So applying the power rule, we have multiplied the power to the coefficient, which is 1. So that becomes 2y. And then we have just copied the y prime there as the derivative. So now what we are going to do next is to isolate the y prime on the other side and then transpose negative 2y on the right side. So here we have obtained 2xy prime minus 2y y prime equals negative 2y. This is actually from here 2 times y, that would be 2y, and then transposing on the right side, that would be negative 2y. That is why we have there negative 2y. And then we also have 2xy prime minus 2y prime. This is because this is from the multiplication of this one, 2 times xy prime, and then minus 2y y prime. And then we have just transposed the 2y on the other side. That's why it became negative 2y. So now, getting the factor of these two terms, of course, it is obvious that the factor of this one is the y prime, which is the derivative or the notation for the derivative in which we included in our differentiation. So the 2xy prime divide y prime, that would be 2x, and then negative 2y prime divide y prime, that would be negative 2y equals negative 2y. And then since we are going to get the value for the derivative, all we just need to do is to divide both sides by 2x minus 2y. And so we obtain y prime equals negative y all over x minus y. So our basis for the term that we are going to divide would be the value beside the y prime. So that is why we obtain y prime equals negative y all over x minus y. Moving on to number 4, we are given f of x equals sine x tan x. So this is simply applying the product rule again. So by applying the product rule, we have obtained f prime of x equals cos x tan x plus sine x sec squared x. And then combining them all together, we obtain cos x tan x plus sine x sec squared x. Since the derivative of sine would be cos, and then we will just copy the tan there, plus copying the sine x, and then getting the derivative of the second function, which is the derivative of tan x is sec squared x. So since we find nothing else to multiply or have common to be multiplied, we will just directly have this as an answer, which is cos x tan x plus sine x sec squared x. Moving on to number 5, we are given f of x equals sine x to the third times cos x squared. So this is also applying the product rule, which we have obtained f prime of x equals cos x to the third. And then, of course, this is applying the chain rule as well, in which before we can proceed, we will first obtain the derivative of the x to the third, which is 3x squared, and then now we can multiply it with cos x squared, which is our v, and then plus sine x cubed by copying the u, and then getting the derivative of cos x squared, which is negative sine x squared times 2x. Since the derivative of x squared is 2x, or the inside function is 2x. So by combining them all together with operation, we obtain f prime of x equals 3x squared cos x to the third cos x squared minus 2x sine x to the third sine x squared. So that would be our answer for number 5 by applying the product rule. By the way, UDV and VDU can be just interchanged, so it can also be VDU plus UDV. So we are now to our number 6. We are given the function f of x equals a to the x all over e x. So we can write this as f of x equals a to the x times e to the power of negative x, since we know that the power of the denominator will always be negative. So we have here our answer f prime of x equals a to the x e to the power of negative x times ln a minus 1. And then we can put on the e to the power of negative x as its denominator. So therefore, we have obtained the answer f prime of x equals ax all over ex times ln a minus 1. So that will be our answer for number 6. Moving on to number 7, we are given the function f of x equals ln or ln 3 all over x. So we already know how to obtain the derivative for in terms of ln. So we have there f prime of x equals 1 all over 3x times negative 3x squared. This negative 3 all over x squared is obtained by getting the derivative of 3 all over x. So multiplying them all together, we have obtained negative 1 all over x. Moving on to number 8, we are given y equals x to the fifth tan x. So this is also applying the product rule, and therefore we have obtained y prime equals 5x to the fourth, which is the derivative of our u, and then copy the tan x plus x to the fifth, copying the u. By the way, this is v here. We just copied the v. Plus x to the fifth, which is our u, and then the derivative of tan x, which is sec squared x. Therefore, our answer by using the product rule for the function y equals x to the fifth tan x is simply y prime equals 5x to the fourth tan x plus x to the fifth sec squared x. For number 9, we are given the function y equals 2 minus x all over 3x plus 1. So this is simply applying the quotient rule, which is again v du minus u dv all over v squared. So our u would be 2 minus x, and our v is 3x plus 1. So by applying the basis of the formula, we have obtained y prime equals 3x plus 1, which is our v, and then negative 1 is our derivative for our u, minus 2 minus x, minus the quantity of 2 minus x times 3. 3 is the derivative of our v. All over 3x plus 1 squared from the basis of v squared. So now we can multiply what we can multiply. So from the first term, we can multiply 3x plus 1 times negative 1, that would be negative 3x minus 1. And then on the other side, that would be 6 minus 3x. So our answer for this would be all over 3x plus 1 squared, of course. We will not forget the v squared. And since negative 3x plus 3x, since this is actually enclosed by a parenthesis, so negative times negative 3x, that would be positive 3x, and then subtracted by 3x, that would be 0. So therefore, we have a remaining constants, which are negative 1 and negative 6, and then negative 1 minus 6, that would be negative 7, and then we will just copy the denominator, which is 3x plus 1 to the power of 2, and therefore, since we have a negative constant from the numerator, our answer would be negative 7 all over 3x plus 1 squared. Hopefully you have grasped the idea or the meaningful process of using the quotient rule. Now for number 10, we are given y equals the square root of 3 minus 2x. So we can rewrite the square root of 3 minus 2x into 3 minus 2x to the power of 1 half. And then we will apply the chain rule for this. So we will multiply 1 half on this one. We will bring down 1 half. Then we will copy the inner function, and then 1 half minus 1 half by apply 1 half minus 1 by applying the power rule, that would be negative 1 half, and then we will obtain the inner function's derivative, which is negative 2. And so by multiplying them all together, we have obtained negative 1 all over the square root of 3 minus 2x. Because negative 2 times 1 half, that would be negative 1. And then we can simply put 3 minus 2x to the power of negative 1 half as its denominator, because we will always know that in terms of having a negative power, of course, it will simply become the denominator of a fraction. So yes, that is our answer for number 10. Moving on to number 11, we are given y equals 2 all over 5x plus 1 to the power of 3. This can be up- this can be obtained through applying both quotient and product rule, but we can simply just use the product rule by simply turning 5x plus 1 to the power of 3 into 5x plus 1 to the power of negative 3. So we will now apply the product rule, and thus we have obtained y prime equals 2 times negative 3. Th- This is not just about the product rule, but rather the chain rule. Since we are applying the chain rule here, we will multiply negative 3 by 2, and then copy the inner function, and then subtract the power, which by negative 1, that turns to negative 4, and then getting the inner function's derivative, which is 5. So 5 times 2, that would be 10 times negative 3, that would be negative 30, and then we will put 5x plus 1 to the power of negative 4 as the denominator of this fraction. Therefore, our answer for this is negative 30 all over 5x plus 1 to the fourth by applying the chain rule. So that is our answer for number 11. Moving on to number 12, we are given the function y equals 2 square root of x minus 1 all over 2 square root of x. So we can simply, to easily answer this one, we can simply turn 2 square root of x into 2x to the power of 1 half, because we know that the power of this radical is 1 half, minus 1 half squared to the power of 1 half. And so, by the way, this is negative 1 half there. And so we have obtained y prime equals x to the power of negative 1 half. Since we multiply 1 half by 2, that would be 1. And we will not just going to copy the 1 there, since it is understandable that it is the x itself. And then 1 half minus 1, that would be negative 1 half. And then we will multiply 1 half. Negative 1 half, that's negative 1 half there. I just missed to put on the negative. So negative 1 half times negative 1 half, that will be 1/4 x. And then subtract 1 half by 1, and that gives us negative 3 halves. So therefore, our answer for this function is y prime equals 1 all over square root of x plus 1 all over 4x to the power of 3 halves. Moving on to number 13, this is simply applying the same thing from number 12. Y equals 3x to the power of 2/3 minus 4x to the power of 1 half minus 2. So, of course, the derivative of 2 is 0 as a constant. And then we just multiplied 1 half to 4, that would be negative 2. And then 1 half minus 1, that would be negative 1 half. And then on the other side, which is our first term, we multiply 2/3 times 3, which is 2, and then 2/3 minus 1, that would be negative 1/3. That's why we have obtained or differentiate this function, and we have obtained the answer y prime equals 2x to the power of negative 1/3 minus 2x to the power of negative 1/2. Moving on to number 14, we are given y equals the square root of x squared plus 2x minus 1. And we can turn this function into x squared plus 2x minus 1 times, x squared plus 2x minus 1 to the power of 1/2. So we will apply the chain rule. So 1/2 times the base, which is 1, and then copy the inside times getting the inner function of this one, which is 2x plus 2. And then multiplying them all together, we have obtained 2x plus 2 all over 2 times the square root of x squared plus 2x minus 1, or simply x plus 1 all over x squared plus 2x minus 1. This is because we have factored 2x plus 2 by 2, so 2 will be put outside and then x plus 1 will be inside. And since we have the denominator there as 2, we have cancelled the 2 from numerator and the 2 from the denominator. So we have remained x plus 1 all over the square root of x squared plus 2x minus 1. Number 15 is y equals x all over the square root of 1 minus x squared. So this is our answer for this one by simply applying the chain rule. Since x all over the square root of 1 minus x squared can be rewrite into x times 1 minus x squared to the power of negative 1/2. So we will simply apply the chain rule for this, and therefore we have obtained y prime equals 1 all over 1 minus x squared to the power of 3/2. Number 16, we have the function y equals ln ex to the all over a y equals ln times e to the x all over e to the x minus 1. So our formula would be, or the process would be, or we can rewrite this as y equals ln times e to the x minus ln e to the x minus 1. And that gives us y prime equals 1 minus e to the x all over e to the x minus 1. And so we have obtained y prime equals negative 1 all over e to the x minus 1. So that would be our answer for number 16. Number 17, we are given the y equals ln sec x plus tan x, and we will now get the answer. So this is the application of for natural logarithm rule, in which we will multiply 1 all over sec x plus tan x times the derivative of this inner function. So the derivative of this inner function is sec x plus tan x plus sec squared x, and then since we multiplied it by 1 all over this denominator, then we will just copy the denominator itself. So our denominator is sec x plus tan x. And since we can factor this out, the numerator, by sec x, so we can cancel the quantity from both numerator and denominator, which is tan x plus sec x, from numerator and denominator. So therefore, we have obtained y prime equals sec x as our answer for number 17. Number 18, we are given y equals tan to the power of negative 1 x over 2. So we will simply apply a rule for this one. So y prime would be equals to 1/2 all over 1 plus x over 2 to the power of 2. And that gives us y prime equals 2 to the power x to the x squared plus 4. That would be for our number 18. Number 19, we are given y equals x squared sine 1 all over x, and x is not 0. So we will simply apply the product rule for this one. And thus, we have obtained y prime equals 2x sine 1 all over x plus x squared cos 1 all over x times negative 1 all over x squared. So combining them all together, based on what we can combine, we have obtained the answer y prime equals 2x sine 1 all over x minus cos 1 all over x. So that is our answer for number 19. Number 20, we are given the function y equals ln times quantity of x times the square root of x squared plus 1. So talk about the rule for natural logarithm or logarithmic function. We are given y, or we can rewrite this as y equals ln x plus 1 half ln times x squared plus 1 as a derivative of this inner function. So now we can obtain y prime equals 1 all over x plus x all over x squared plus 1, and that gives us y prime equals 1 all over x plus x all over x squared plus 1. Since ln x is 1 all over x, and then this second one is x all over x squared plus x. And then we are just obtain the answer for number 20. Number 21, so our answer for number 21 is y prime equals 4 all over e to the x plus e to the power of negative x to the power of 2. That is our answer for number 21. I have just directly input the answer there because it can easily be obtained by using the quotient rule. Number 22, we are given y equals 1 all over 2 sine 2x. And so we can write this as y equals 1 half times sine 2x to the power of negative 1. And by applying the chain rule, we have obtained negative 1 half times sine 2x to the power of negative 2 times 2 cos 2x, and then the derivative of 2x, which is 2. So multiplying them all together, based on what we can multiply, we have obtained there negative cos 2x all over sine squared 2x. So again, we have put sine 2x to the power of negative 2 as a denominator because of its negative power. So number 23, our answer for number 23 is y prime equals negative e to the power of negative x times cos 2x plus 2 sine 2x by using the rule for e rather, or for Euler. So number 25, we are given y equals x ln to the third x. So we will just simply apply the product rule, which is y prime equals ln to the third x plus x times 3 ln squared x times 1 all over x. So therefore, we have obtained y prime equals ln to the third x plus 3 ln squared x. By the way, we have just obtained ln 3x since the derivative of x is 1, so ln to the third x times 1 is simply just ln to the third x. And then multiply all this together from here, we have obtained 3 ln squared x. Now, moving forward to number 26, we are given y equals sine to the power of negative 1x minus 1 minus x squared. So, we can write this one as y prime, or we have obtained the derivative of this one as y prime equals 1 all over the square root of 1 minus x squared plus x all over the square root of 1 minus x squared. So now this is simply applying the rule for the product rule. And therefore, we have obtained the answer y prime equals 1 plus x all over the square root of 1 minus x squared. Since we just have the same denominator for this one, so we can combine them all together into one fraction, and then we will just add 1 plus x as its numerator. We are now to our number 28, which is x plus cos times the quantity of x plus y equals 0. So this is implicit differentiation again, and we will just simply use the process that we used earlier. And by isolating y, or the y prime, we have obtained our answer, which is CSC times x plus y minus 1. Number 29 is implicit differentiation as well. We have the function x to the third minus xy plus y to the third equals 1. So by getting the derivative of each of the terms here, we have obtained 3x squared minus x y prime plus y plus 3y squared y prime equals 0, since the derivative of a constant is again 0. So we will just transpose on the other side for us to isolate y. So we transpose negative y plus 3x squared, and it became y minus 3x squared. It's from here and from here. And we now have negative x plus 3y squared times y prime. So for us to obtain the answer, we will simply divide both sides by negative x plus 3y squared. And therefore, by applying it, we obtain our answer, y prime equals y minus 3x squared as the numerator from this, all over 3y squared minus x, as we use this one to divide this one, or this terms here. So we obtain y minus 3x squared all over 3y squared minus x as our answer. So number 30, this is so simple. Y equals e to the x squared. So we know the process of this one. We will simply get the derivative of the power of this e, which is the Euler. So derivative of x squared, that would be 2x, and then we just brought it all down and then copy the e to the x squared. So combining them all together, we simply obtain 2x e to the x squared as our answer for number 30. Number 31, we have here y equals tan x all over 2x minus 3. So we will simply apply the quotient rule, simply as that, obviously. So applying the process of a quotient rule, we obtain y prime equals 2x minus 3 times x squared x minus 2 tan x all over 2x minus 3 squared, because as far as I can remember, our formula for quotient rule is v du minus u dv all over v squared. So thus, by applying operation, our answer for this one is 2x minus 3 times the quantity of x squared x minus 2 tan x all over 2x minus 3 squared. That is our answer for number 31. Moving on to number 34, we have the function y equals sec 8x, and the answer for this one is y prime equals 8 sec 8x tan 8x. Number 35, y equals 5e to the 3x plus sine x. So getting this, we will get each of the derivative of the term. So the derivative of 5e to the 3x is simply 15e to the 3x, and the derivative of sine x is simply cos x. Since we cannot add them together, then we will have these terms as our answer. So our answer for this one will be y prime equals 15e to the 3x plus cos x. Number 37, we can apply the quotient rule, but in this case, I just use the chain rule, since I can rewrite 2x minus 3 to the power of 4 as 2x minus 3 to the power of negative 4. So there, by using the chain rule, I have obtained 5 times negative 4, since I have multiplied the power negative 4 to the 5, and then I just copied the inner function, which is 2x minus 3, and then I just subtracted by negative 1 the negative 4 as our power, and then I just got the derivative of the inner function to x minus 3, which is 2. So 5 times negative 4 times 5, that would be 40, and then that would be negative 40 rather, and I just put as the denominator the 2x minus 3 to the power of negative 5. Because again, when we have a quantity that has a negative power, that would be directly put as the denominator when we are going to simplify our answer. So therefore, our answer for number 37 is 5 prime of x equals negative 40 all over 2x minus 3 to the power of 5. That's number 37. Moving on to number 39, we have here f of x equals negative 10x squared minus 3 all over 4x plus 1. And this is simply applying the quotient rule. And by applying the quotient rule, we obtain 4x plus 1 times negative 20x as derivative of our numerator, and then minus negative 10x squared minus 3. I just copied the numerator since that's the u, and then times 4, which is the derivative of 4x plus 1 all over 4x plus 1 squared. So multiplying each term from the left and the right side, 4x plus 1 times negative 20x minus the quantity of negative 10x squared minus 3 times 4. That simply gives us negative 40x squared minus 20x plus 12 by simply combining the right or the like terms. And then we will just copy the denominator, which is 4x plus 1. And then with respect to the formula which has square on it, then we will just put squared on our v, which is 4x plus 1 squared. And therefore, our answer is f prime of x equals negative 40x squared minus 20x plus 12 all over 4x plus 1 squared. So our answer for number 40, or the process for number 40, is y equals x to the third ln x. So we will simply apply the product rule, and thus it gives us 3x squared ln x plus x cubed times 1/3. And therefore, by combining them all together, we have obtained 3x squared ln x plus x squared. So that is our answer for number 40. And for our, this is applied with the product rule. That's why we obtain the derivative of x cubed as 3x squared, and then we just copied ln x plus x cubed, in which we just copied, and then the derivative of ln x, or x cubed ln x, is 1/3. And that's the process for number 40. And that made us obtain the answer. And of course, by the way, this is not 1/3. I just noticed why it became 1/3. This is actually 1 over x. 1 over x. That's 3x squared ln x plus x cubed times 1 over x. That's why x cubed times 1 all over x is now become x squared. I'm sorry for the error there. Number 41, we have y equals the square root of 4x plus 2, in which we can simply rewrite as 4x plus 2 to the power of 1/2, and then we will just simply apply the chain rule, in which we will just multiply the power to the base, which is 1/2 there. Our base actually is 1 there. It's not visible because it is understandable that in this case, it has always 1 as its base. So 1/2 times 1, that's 1/2. And then we just copy the inner function. And then we just subtracted the power by negative 1. That gives us negative 1/2. And times 4 as the derivative of our inner function. So 4 times 1/2, that would simply be 2. And then there we have obtained 4 all over 2 square root of 4x plus 2. And in this case, you haven't yet multiplied it with 1/2, since you will put it in a fraction, in a fraction pa. So 4 divided 2, that would be 2 as a remaining number for our numerator. And then since 2 is cancelled, the remaining terms is the square root of 4x plus 2. So our answer for number 41 is 2 all over the square root of 4x plus 2. Number 42, we are given sin x minus cos y minus 2 equals 0. So this is simply applying the implicit differentiation. The derivative of cos x, the derivative of sin x rather is cos x, derivative of negative cos y minus 2, that would be sin y prime. So the very reason why it became positive because since it is already negative here, and then the derivative of cos y is negative sign, so negative times negative, that will be positive. And we just copy the derivative there, which is the y prime, and then we will isolate that one. And then the derivative of the constant too, that is 0. So we simply transpose cos x, that became negative cos x, and then since sin y prime is on the left side with the y prime, we will use this to be something that would divide the negative cos x. And by that, we have obtained our answer, y prime equals negative cos x all over sin y. Moving on to our number 43, we have there 3x squared minus 2xy plus 5y squared equals 1. This is again implicit differentiation in which we will get to obtain the derivative of each of the terms. So derivative of 3x squared, that would be 6x. Derivative of 2xy, that would be 2 times the quantity of xy prime plus y. And then derivative of 5y squared, that would be 10y y prime. Since in terms of getting the derivative of y, we will always include the y prime. Unless or except from here, since it doesn't have y, therefore the answered term will not contain the y prime. It will only be contained on those terms that contains y. And the derivative of 1 is, as constant, is 0. So of course, we will transpose 2y minus 6x on the other side. And then we are remain here with negative 2x plus 10y y prime as factored from negative 2xy plus 10y prime. Since we have transposed the 2y from there, since negative 2 times y transpose became positive, so that's 2y, then 6x became negative 6x. So multiplying both sides or dividing both sides with negative 2x plus 10y, we will now obtain our answer, which is y prime equals y minus 3x all over 5y minus x. And that's simply how we obtain number 43. Number 44 is x squared plus 2xy equals y squared, which is again implicit differentiation. And now we will obtain the derivative of each of the terms. Derivative of x squared, that's 2x. Again, it will not contain y prime because it the term doesn't have y. And then for 2xy, of course, it will contain y prime. So we will have 2xy prime plus y. And then equals y squared, it gives us 2y y prime. Since the derivative of y squared is 2y, and then we will copy the y prime. And then we are going to transpose the 2x minus 2y on the other side, and then we will prioritize on the left side the terms that has y prime on it for us to be able to isolate the y prime and then get the answer. So the common term for this one is 2x minus 2y. And since we also have negative 2x minus 2y divided by the quantity beside the y prime, hence we have obtained negative x plus y all over x minus y. So that is how meaningful is the implicit differentiation. Hope you have understand the all rules in the application of derivatives. It contains the product, the quotient, the chain, the power, and also for the implicit differentiation. We are now in our part 2, which is about multiple choice. for each of the items. And our first question goes like this. Which of the following functions are not everywhere continuous? Considering the five choices, the correct answer for number one is letter A. This is because at x equals -2, denominator becomes 0, so that is discontinuous. And the correct answer for number one, that's letter A. For number two, which of the following functions are not differentiable? So considering again the five choices, the correct answer for number two, that's letter A. It's because absolute value has a sharp corner at x equals 0, so derivative does not exist there. So the answer for number two is A, which is f of x equals the absolute value of x. Number three, find the third derivative of the function f of x equals 5x squared times x plus 47. So we will get the derivative through applying the product rule, and thus our first derivative for this one is 15x squared plus 470x, and then getting the derivative of each term, in which we will get the second derivative. That would be 30x plus 470, and then getting the derivative of this terms again, and thus it gives us 30. Looking upon the choices, we do not see 30 there. Therefore, our answer for number 3 is letter E, none of the choices. Number 3 answer is letter E. Number 4, suppose that you have the following utility function u of x equals the square root of x. Find negative u double prime of x all over u prime of x. So, of course, we will get the double prime of this function and then divide it by the first derivative of this function. And, of course, by calculating it, the derivative of, or the first derivative of the square root of x is 1/2 x to the power of negative 1/2. Since we can transform square root of x into x to the power of 1/2 and then multiply 1/2 to the base or to the coefficient which is 1 and then subtract 1 from 1/2, and therefore it gives us 1/2 x to the power of negative 1/2. And then we will get the derivative of this one, which is 1/2 x to the power of negative 1/2. And the derivative of 1/2 x to the power of negative 1/2, by applying the power rule, it gives us negative 1/4 x to the power of negative 3/2. So that is our that is our second derivative for the function square root of x. And since we have obtained the double prime of this one, we will now divide the second derivative by its first derivative. So negative 1/4 x to the power of negative 3/2 divided by 1/2 x to the power of negative 1/2. By computing them all together, it gives us 1 all over 2x. So from the choices, we cannot find 1 all over 2x here. Therefore, our answer for number 4 is letter E, none of these. Number 5, find the second derivative of the function f of x equals 5x squared times the quantity of x plus 47. So we will be able to obtain the second derivative of this function through the use of the product rule, which is udv plus vdu or vdu plus udv. So the first derivative of this one is, the first derivative of this one is 15x squared plus 470x, and then getting its second derivative by getting the derivative of each term, it gives us 30x plus 470. So the answer for number 5 is 30x plus 470. So number 5 answer is letter B, 30x plus 470 as the second derivative. Number 6 question. The derivative of ln e to the x equals 1. Is the statement true or false? So the correct answer for this one is letter A, which is true. It's because ln e to the x equals x, and derivative of d over dx of x, that is 1. And that is true. Number 7. If f of x equals x to the fourth minus 4x cubed plus 4x squared minus 1, then the set of values of x for which the derivative equals 0 is. So the very first thing that we need to do is differentiate the given function, which is 4x cubed minus 12x squared plus 8x, and then we will factor them all together, which is now 4x times the quantity of x squared minus 3x plus 2, and then factor out the inner there, which is the x squared minus 3x plus 2, which is x minus 1 and x minus 2. And since we are able to factor them all together, for x has the 0 solution, x minus 1 has 1 as its solution, and x minus 2 has 2 as its solution. Therefore, the correct answer for number 7 is letter E, 0, 1, and 2. Moving on to number 8, if f of x equals 16 square root of x, then f double prime of 4 is equal to. So before we can substitute 4 into the function, we will first get the second derivative of 16 square root of x. We all know that this function, which is 16 square root of x, can be written as 16x to the power of 1 half. And its first derivative is simply 1 half times 16, that's 8x to the power of negative 1 half, since we have subtracted 1 from 1 half. Therefore, the first derivative of 16 square root of x is 8x to the power of negative 1 half. And then we will again get the derivative of it, which is now the second derivative. So the derivative of the first derivative or the second derivative from the first derivative, we will just simply multiply negative 1 half to 8, which is now negative 4, and then subtract negative 1 half by 1. So therefore, the second derivative of 16 square root of x is negative 4x to the power of negative 3 halves. And this, we can also rewrite this as negative 4 all over the square root of x cubed. So now we can substitute 4 to the x cubed. So 4 times 4 times 4, that will be 64. And then the square root of 64, that is 8. So our denominator is 8, and then our numerator is negative 4. So negative 4 over 8 can also be written as negative 1 half. Therefore, our answer for number 8 is letter E. Number 9 question. F of x equals ln x cubed, then f double prime of 3 is, so this is same case from number 8. We will first identify the second derivative of ln x cubed. And the second derivative of ln x cubed is negative 3 all over x squared. And of course, we will simply substitute 3 on it to the x, so negative 3 all over 3 squared, and that gives us negative 3 over 9, which is also negative 1/3. So our answer for number 9 is simply letter A. Number 10, if a point moves on the curve x squared plus y squared equals 25, then at 0, 5, d2y over dx squared is. So from the choices, the correct answer is letter D. It's because we are going to differentiate 2x plus 2y y prime, and that will be 0. Or we will differentiate x squared plus y squared equals 25, which is 2x plus 2y y prime equals 0 from the basis of implicit differentiation. And then we will differentiate it again. So y double prime equals negative y minus xy prime all over y squared. And then at 0, 5, we're simply substituting 0 and 5 to the second derivative. We have obtained negative 5 over 25. And then negative 5 divided 25 can also be negative 1/5. So our answer for number 10 is simply letter D. Number 11. If f of x equals f to the x and f to the 1.002 is approximately 1 is approximately 5.016, which is closest to f prime of 1. So what we are going to do is to estimate f prime of 1. So we are going to use the derivative definition, which is f prime of 1 is approximately 5.016 rather minus 5 all over 0.002. So the answer for that will be 0.016 all over 0.002, which is equal to 8. So the answer for number 11 is letter 8. So the closest to f prime of 1 is 8, which is letter D. Number 12. The function f of x equals x to the power of 2/3 on negative 8 and 8 does not satisfy the conditions of the mean value theorem because so why it doesn't satisfy? This is because it is undefined at x equals 0 because f prime of 0 does not exist. And mean value theorem requires differentiability on negative 8 and 8. And so our answer for number 12 is letter E. Number 13. All but one of the function is differentiable for real values of x, which is not differentiable for at least one real value of x. So the correct answer for number 13 is letter C, which is h of x equals the absolute value of x, because it is not differentiable at 0. Number 14. A function f has the derivative shown. Which of the following statements must be false? So the correct answer for number 14 is letter D. It, f has a jump discontinuity at x equals a. Because as we can see, it, it has obviously a jump discontinuity at x equals a. Number 15. The function f whose graph is shown has f prime equals 0 at x equals, meaning to say we will identify which of this has the f of prime equals 0. So what value of x that it has f prime equals 0. So number 15 and 2 is letter A at 2 only because graph shows horizontal tangent at x equals 2. Number 16, a differentiable function f as the value shown, and we are going to estimate f prime 1.5. So the correct answer for number 16 is 40. This is simply applying the symmetric difference, which is f of 1.6 minus f of 1.4 all over 1.6 minus 1.4, which is now become 22 minus 14 all over 0.2, and applying operation that would be equal to 40. So our answer for number 16 is letter D, which is 40. Number 17. Water is poured into a conical reservoir at a constant rate. If h of t is the rate of change of the depth water, then h is the correct answer for number 17 is letter D, nonlinear and increasing. Because as the cone fills, radius changes with height, so nonlinear, and depth increases continuously. So it means that h is nonlinear and increasing. 18. If f of u equals sine u and u equals g of x equals x squared minus 9, then f of g prime of 3 equals. So we will simply apply the composite or the chain rule for this one. So f of u equals sine u and g of x equals x squared minus 9, and f of g of prime is equal to f prime g of x g prime of x from the chain rule. And that would be equal to cos times x squared minus 9 times 2x, which gives us 6, which is at letter C. Because at x equals 3, substituting 3 on it, 6 cos 0, that is 6. So number 18 is letter C, which is 6. Number 19. If f of x equals x all over x minus 2, or x all over x minus 1 squared, then the set of x for which f prime of x exists is number 19. The correct answer for number 19 is letter E. Derivative exists except denominator 0. You need to say x is not equal to 1. You need to say x is not all reals except x equals 1 because x shouldn't be equal to 1. Number 20. If f of x equals 1 all over x squared plus 1 and g of x equals the square root of x, then the derivative of f of g of x is, so this is simply applying the chain rule. And by applying the chain rule for this one, the correct answer for number 20 is letter B, or negative 1 all over x plus 1 squared. Since x plus 1 plus 2 can be put as the denominator, or negative 1 all over x plus 1 squared, it's just the same as negative times the quantity of x plus 1 to the power of negative 2. Number 21. If f of a equals f of b equals 0, and f of x is continuous with a and b, then the correct answer for number 21 is letter C. Because if f of a equals f of b and continuous or differentiable, then sum c satisfies f prime of c equals 0. So the correct answer for 21 is letter C. Number 22. Suppose g of x minus g of 0 all over x equals 1. It follows necessarily that number 22 answers letter D. This is exactly the derivative definition at 0, meaning to say g prime of 0 equals 1. Number 23. At how many points on the interval a and b does the function graph satisfy the mean value theorem? So the mean value theorem points is what we are going to talk here. And graph appears to have 3 tangents parallel to second line, meaning to say the correct answer for number 23 is letter D, 3 tangents parallel to second line. Number 24. Given the graph below, f of prime of 3 is mostly closely approximated by, so we are going to estimate slope at x equals 3, and the tangent line slope is approximately 1.5, which is letter C. So the answer for number 25 is letter E. It's none of this because the answer from my calculation is approximately 155,325, but it's not on the choices. So the correct answer for 25 is letter E. So number 26, determine f prime of 2 for f of x equals x squared plus 4x minus 1. So in order for us to substitute 2, we will first get the derivative of x squared plus 4x minus 1, which is 2x plus 4. And right after that, we will now substitute 2 into it. So 2x, substitute 4, that would be 4, plus 4, that's 8. So number 26 is letter B. Number 27. Find an equation for the line tangent to given curve at the given value of x such that y equals x squared minus x at x equals negative 3. So tangent line to y equals x squared minus x at x equals negative 3. So step 1, we will find the point xy, and the point are negative 3 and 12, and then find the slope m, which is the y prime, which is negative 7. And then the step 3 equation of the tangent line, which is y minus y1 equals m times the quantity of x minus x sub 1. So that is y equals negative 7x minus 9. So the correct answer for Number 27, that's letter C. And that's actually negative 7x minus 9. It's not negative 7x minus 9. So still therefore, since there is an answer there which is none of this, then we can answer none of this. Since I think there is a supposed to be correction for letter C, but since we have we have letter E from the other hand, which is none of this, so our answer for 27 is letter E. 28. Find the slope of the line tangent to the graph of the function at the given value of x, such as y equals 9x to the power of 5 halves minus 7x to the power of 3 halves at x equals 4. So we will find the slope of a tangent to y equals 9x 5 halves minus 7x 3 halves at x equals 4. So in step 1, we are going to differentiate this function, which is 9x 5 halves minus 7x 3 halves, which gives us 45 halves x to the power of 3 halves minus 21 over 2x to the power of 1 half. And then we will substitute the number into it. So for the first one, we have for 45 halves times 8 minus 21 halves times 2. That would be 180 minus 21, which gives us 159. Therefore, our answer for 28 is letter A. Number 29. A particle moving in a straight line covers a distance of x centimeter in t second, where x equals c cubed plus 6t squared minus 15t plus 18. When does the particle stop? So for number 29, all we just need to do is to get the derivative of it. And that would be tt squared plus 12t plus 15. And then that is going to factor or divide by 3. And that gives us t squared plus 4t minus 5. And then factor, we have t plus 5t minus 1. And we are going to ignore the negative t, so our answer is 1 second. So again, we will get the derivative into it, and then divide it by 3, and then factor them together, and that gives us negative 5 and positive 1, and we will ignore the negative 5, but we will consider the 1, which is 1 second. So 29 is letter C. Number 30, the graph of G prime is shown here. Which of the following statements is or are true of G at x equals A? So the correct answer for number 30, that's letter C, which is 1 and 2 only. Meaning to say G is continuous and G is differentiable. Number 31. The position S in meters of an object moving in a straight line is given by S of t equals 5t times the quantity of t minus 2 to the power of 2, where t is the time in seconds. Determine the velocity of the object at time t equals 1. So we are going to determine the velocity of the object at time t equals 1. So we are going to derive this one, getting its first derivative by using the product rule. And by that, we obtain negative 5 meter per second, which is letter D. The correct answer for number 31 is letter D. Number 32. If f of x equals the square root of x squared minus 1 and g of x equals x plus 1, which expression is equal to f of g of x? So number 32 answer is letter B, which is the square root of x squared plus 2x. We will simply plug in the values of x plus 1 to the f of x value. So our answer for 32 is letter B. Number 33, determine the slope of the tangent So the power of y equals 2x minus 3x squared, the power of 2 at 1 and 1. So number 33 answer, we will differentiate the given function by using the chain rule, and we are going to substitute 1 into it. So our answer for it as its chain rule is 2 times the quantity of 2x minus 3x squared times 2 minus 6x. Again, chain rule is the derivative of the inner and the outer function with also respect to the power. So by substituting 1, it gives us 8. So 33 answer is letter D. Number 34, find the derivative of f of x equals 7x to the power of negative 4 and find f prime of 2. So all we just need to do is to find the derivative of this 34 and then substitute 2 into it. So derivative of 7x to the power of negative 4, that's negative 28x to the power of negative 5, and then substitute 2 into it. That gives us letter C, which is 0.87. Number 35. Determine dy over dx for y equals x squared minus 4 all over x squared plus 4 when x equals 1. So we will determine the derivative of this one and then substitute 1 into it. Number 36. So A, negative 16 over 25, B, 4 over 25, C, 16 over 25, D, 1 or letter E, none of this. So the correct answer for number 35 is letter E, none of this. So we are now number 36. The function f of x equals x all over sine x is increasing in 0 and 1, which can be found in letter A. 36 answer is letter A because the derivative is positive on 0 and 1. Number 37, the definition of the first derivative of a function f of x is, so I can still remember how or what Ma'am Normina has taught us in terms of the first derivative, and based on what I can remember from T.C. Waghold, which she discussed to us, the correct answer is letter B, which is f of x equals f times the quantity of x plus delta x minus f of x all over delta x. Number 38. The velocity of a body as a function of time is given as v of t equals 5e to the power of negative 2t plus 4, where t is in seconds and v is in meter per second. The acceleration in meter per second squared at t equals 0.6 s or second is, so since the acceleration is asked, we are going to get the derivative of this velocity function given. So, and the derivative of this function, which is 5e to the negative 2t plus 4, its derivative is negative 10e to the power of negative 2t. And so, substituting 0.6 into it, it gives us the answer negative 3.012. So 38 is letter A. Number 39. Given y equals sin 2x dy dx at x equals 3 is most nearly at, so number 39, we will simply get the derivative of given the function and substitute 3 into it. So the derivative of the given function is y prime equals 2 cos 2x. And at x equals 3, substituting 3 into x of 2, that gives us 2 cos 6. And 2 cos 6 is approximately 1.920, which is 39 letter C. Number 40. For the function f of x equals x plus 1 over x and x is an element of 1 and 3, the value of C for the mean value theorem is, so the correct answer for number 40 is letter B, which is the square root of 3. So in this case, the process is just simply getting the average slope, which is the 2/3, and then getting the derivative of 1 plus 1x squared, and then equate it to 2/3. And by that, it gives us the square root of 3. So number 41. The value of C in Rolle's theorem when f of x equals 2x cubed minus 5x squared minus 4x plus 3 equals x is an element of 1/3 and 3 is, so the correct answer for 41 is letter A, only 2. 42. For the function f of x equals x times the quantity of x minus 2x is an element of 1 and 2, the value of C for the mean value theorem is, the 42 answer is letter D, 3/2. This is because you will simply get the average slope and then get the derivative and set it equal to the average slopes. And that gives us x equals 3/2 from 42, letter D. Number 43. The value of C in Rolle's theorem when f of x equals e to the x sine x, x is an element of 0 pi is, the correct answer for number 43 is letter D, which is 3 pi all over 4. So we will simply get f of x equals e to the x sine x, get the derivative, which is e to the x sine x plus cos x, and then set it to 0, and that gives us tan x equals -1. And in 0 pi, we will obtain x equals 3 pi 4. So that's 43, letter D. Number 44, the cost function of a firm is c equals 3x squared plus 2x minus 3. Then the marginal cost when x equals 3 is, so by obtaining the marginal cost, we will just simply get the derivative. And we will substitute 3 into it. So the derivative of it is 6x plus 2. And substitute 3 into it, that gives us 20. So 6x plus 2, 6 times 3, 18 plus 2, that is 20. So 44 is letter B. A side of an equilateral triangle expands at rate of 2 centimeter per second. The rate of increase of its area when each side is 10 centimeter is, so number 45 answer is letter B, which is 10 square root of 3. In this case, we have the area equals square root of 3 over 4 s squared, and then differentiate it, and at s equals 10 and d over dt equals 2, we have 10 square root of 3, which is letter B. And now let us move on to number 46. So number 46. Number 46, the function f of x equals x cubed minus 6x squared plus 15x minus 12 is, so the correct answer for number 46, so by calculating it based on how the function goes on, whether it's increasing or decreasing, the correct answer for number 46 is letter B, increasing on open parenthesis, infinity and 2 bracket, and decreasing in open parenthesis 2 and infinity close parenthesis. So number 47. So number 47 question goes like this. The radius of a sphere is changing at the rate of 0.1 centimeter per second. The rate of change of its surface area when the radius is 200 centimeter is, so based on the calculation for number 47, the correct answer for number 47 is letter C. The correct answer for 47 is letter C, which is 165. This is because S equals 4 pi r squared, and getting the derivative, that will be 8 pi r, and given r equals to 100. So, and dr over dt is 0.1. So therefore, we will obtain 160 pi. So 48 question. A cone whose height is always equal to its diameter is increasing in volume at the rate of 40 centimeter cube per second. At what rate is the radius increasing when its curricular base area is 1 meter squared? So this is about cone problem, and the height equals diameter, h equals to r. So the volume would be V equals 1 over 3 pi r squared, h which is equal to 2 over 3 pi r cubed. To differentiate them together in the base area, so the correct answer is none of the choices. Because the answer is actually 20 centimeter per second, but it's not on the choices. Number 49, if the rate of change of volume of a sphere is equal to the rate of change of its radius, then its radius is equal to, the correct answer for number 49 is letter D, 1 all over 2 square root of pi unit. Number 50. So this is about a man of height 6 feet walks at a uniform speed of 9 feet per second from a lamppost fixed at 15 feet height. The length of his shadow is increasing at the rate of, so number 50 answer is letter C, which is 6. This is simply using similar triangles. 15 all over x plus 15 all over x plus y equals 6 all over y. To solve, 15y equals 6x plus 6y, and that would be 9y equals 6x, since we have transposed 9 on the other side. And dividing both sides together, it gives us 2/3 x. And to differentiate it, 2/3 times 9, that would be 6. So number 50 is letter C, which is 6. 51. A sphere of radius 100 millimeter shrinks to radius 98 millimeter. Then the approximate decrease in its volume is, so the approximate decrease in its volume from number 51 is letter E. It's not listed since the answer 8 is 80,000 pi. 52. The correct answer for 52 question is letter D, positive or negative 2. Correct answer for number 52 is letter D, since we can see there positive and negative 2. 53, the correct answer for number 53 is letter C. The question goes, the maximum value of f of x equals x minus 2, x minus 3 squared is, the correct answer for 53 is letter C. This is because we will differentiate the x minus 2 and x minus 3 squared, which is x minus 3 times 3x minus 7. And the critical points for this one is 3 and 7 over 3. And to evaluate them together, f of 3 is 0 and f of 7 of 3 is equal to 4 over 27. So therefore, the maximum is 4 over 27. 54. The smallest value of polynomial 3x to the fourth minus 8x to the third plus 12x squared minus 48x plus 1 on 1 on 4 is, the correct answer for number 54 is letter C, which is negative 59. We are just going to evaluate endpoints and critical points on 1 and 4, and the minimum value obtained is negative 59. Number 55. The function f of x equals 2x cubed minus 3x squared minus 12x plus 4 has, so the correct answer for number 55 is letter C. It has 2 critical points giving 1 max and 1 minimum point. So this is simply getting the derivative of 2x cubed minus 3x squared minus 12x plus 4. And the derivative is 6x squared minus 6x minus 12. And to factor the function, we have 6 times the quantity of x minus 2 times the quantity of x plus 1. So from that, we can have the idea that it has 2 critical points, giving 1 minimum and 1 maximum. Therefore, the correct answer is letter C. Number 56. Consider the following function. Which of the function is are increasing everywhere in 0 and 1? So the correct answer for number 56 is letter D, the 1 and 3 only. This is because e to the x is increasing 2x squared, it's negative sine x, and 2x minus cos x, negative near 0, it's not always increasing. So number 2 is not always increasing. So 3, it's increasing. So the correct answer for 56 is letter D. 1 and 3 only. Number 57. The cubic equation x cubed minus 2x minus 8 equals 0 has, so the correct answer for 57 is letter E. It should have one root between 2 and 3 only. Since it's not here, so it's letter E, none of this. Number 58. The curve y equals x cubed minus 2x minus 5 has blank at x equals square root of 2/3. So number 58 answer is letter A. It has a concave half shape. Since y equals x cubed minus 2x minus 5 has the double prime of 6x, and at x equals the square root of 2/3 is greater than 0, and y prime is greater than 0 as well. So it is a concave up shape. So number 59 question, the absolute maximum value of y equals x cubed minus 3x plus 2 in x is greater than or equal to 0 but lesser than or equal to 2 is, so the correct answer for 59 is letter C. It's because y equals x cubed minus 3x plus 2 has endpoints and critical points, and it has maximum on 0 and 2. And the correct answer, since it is maximum on 0 and 2, the correct answer is 4, which is C. So now let us move on to number 60. Water is flowing into a right circular conical vessel 45 centimeter deep and 27 centimeter in diameter at the rate of 11 cc per minute. By the way, cc is I think ml, I guess, the cc. How fast is the water level rising when the water is 30 centimeter deep? So in this case, we will simply use related rates for cone, dH over dt, which is approximately 0.043. So the correct answer for this is letter B. We are now in number 61. What will be the differential function of log x squared plus 4? So the correct answer for 61 is letter A, which is 2x all over x squared plus 4. Because we know the rule for log, it will be 1 over x squared plus 4 times the derivative of x squared plus 4. And derivative of x squared plus 4 is 2x. So therefore, the derivative of this one is 2x all over x squared plus 4. Now, moving on to number 62. It talks about average rate of change. What will be the average rate of change of the function y equals 16 minus x squared between x equals 3 and x equals 4? So the average rate of change is given f of 4 minus f of 3 all over 4 minus 3. So f of 4 is 0 and f of 3 is 7. All over 4 minus 3 is 1. So negative 7 over 1, that's negative 7. So the correct answer for 62 is letter B. Now let us move on to number 63. Given the question, Given the question, a 5 feet long man walks away from the foot of a 12.5 feet high lamppost at rate of 3 miles per hour. What will be the rate at which the shadow increases? So in this case, we are going to find the rate at which the shadow increases. So at which rate does the shadow increases? So the correct answer for number 63, according from the formula that we've used, is basically letter D, 3 miles per hour. Moving on to number 64, a ladder 20 feet long leans against a vertical wall. If the top end slides downwards at the rate of 2 feet per second, what will be the rate at which the slope of the ladder changes? So number 64 answer is letter D, negative 25 over 54. So we will just simply get the slope, which is m equals y over x, and differentiate it. And then for the step 2, we are going to assume the standard point at x equals 12 and y equals 16. And from that, by computing the slope change, we will obtain negative 25 on over 54. By the way, looking back to number 63, it's actually letter C. It's not letter D. It's because the man height is equal to 5 feet and the lamppost is 12.5 feet. Walking speed is 3 miles per hour. That would be dx over dt equals 3. And of course, similar to triangles, let x distance from man to post and s equals length of the shadow. So we are going to differentiate all together, and then it gives us 2 million per hour. No, 2 mile per hour rather. So 63 is letter C. Number 65. A particle moving in a straight line covers a distance of x centimeter in t seconds. For x equals t cubed plus 6t squared minus 15t plus 18, what will be the velocity of the particle at the end of 2 seconds? So 65, velocity at t equals 2, and x equals t cubed plus 6t squared minus 15t plus 18. So derivative of velocity, which is 3t squared plus 12t minus 15, and then we are going to substitute 2 into it, and that gives us 21 centimeter per second, which is letter C. 65 is letter C. Number 66, a particle moving in a straight line covers a distance of x centimeter in t second, where x equals t cubed plus 6t squared minus 15t plus 18. What will be the acceleration of the particle at the end of 2 seconds? So we will just simply get the derivative of the given function, which is the velocity. And that gives us 60 plus 12. Since we will get the second derivative of this one because this is the position. And the first derivative is 6, the first derivative is 3t squared plus 6 plus 12t minus 15. And then getting its second derivative, that would be 60 plus 12. And we are going to substitute 2 into it. Substituting 2 into it, it gives us 12 plus 12, which is equal to 24 centimeter. And our answer is 24 centimeter per second squared. So so that would be all for the explanation for the final examination, which are coming from the part 2 of the exam. That will be all. Thank you so much, Ma'am Nermina Batukan. God bless you.